Assalamualaikum. So now our discussion is on solving the second order ordinary differential equation, which will lead into boundary value problem. This problem is called boundary value problem. This is part 5 of our discussion on ODE. So the problem is this one here. We are given a function second order ODE in the form of ax y double prime plus bx y prime plus cxy equal dx. A, b, c, and d are all function of x. No y here. So this kind of function is called linear ODE of order 2. So we are given x0, y0, which is the first boundary on the left, and xn, yn, which is the second boundary on the right. So here is the diagram. x0, y0 are given, both of them are given, xn, yn are given, and in this case is the number of intervals. We partition to n intervals here. Each interval have the width of h. So h is related to n through this equation here. xn minus x0, xn the last value, minus x0 the first value, divided by n is h. So we need to find y1, y2 until yn. So we are given values on the left and the right. We need to find the values in between. This one here. So that's the problem. Okay, so the problem can be solved with this description here. We need to have two stages of two steps actually to solve this problem. First is the given problem is reduced into a system of linear equations of size n minus 1 and minus 1. So in order to do that, we need to find the finite difference formula. So this is the first part of the problem, to find the finite difference formula. Second part is, once we get the system of linear equations, we can apply the methods that we discussed before, which is solving a system of linear equation to find the solution. So the methods can be Gaussian elimination method, Kraut method, Kolarski, Thomas, and so on. So this is the one that we need to do. Okay, so the first part of the problem is to find this finite difference formula. So to do that, we are given here. We need to make the equation x and y into its finite form. Finite form means x will transform into xi, y will transform to yi. Y is, I in this case is the finite form. I will go from 0, 1, 2, 3, and so on. So here is the formula that we need. From central difference rules, we have the first derivative, which is this one here. It's approximated as this one here. Second derivative is this one here. So that means we have the first derivative, second derivative. With that, we can eliminate the form that there's this one here, ax y double prime. We can eliminate y double prime and y prime. So this is a problem. So in that case, x will be transformed to xi, y will be transformed to yi. So this one here becomes this. So we eliminate y double prime. This is what we get. And then x and y, put I subscript there. So we have this, the first one, the first term. The second term, y prime, we take this equation, replace, and this is what we get, this one here. And then c, y remain unchanged, and d also unchanged. So with the substitution of y prime and y double prime, we have a new equation, which is this one here. Okay, then the next step is to simplify this equation. To do that, we need to find the common denominator, h squared and 2h. The common denominator is 2h squared. So we do that. So 2h squared means the first term we have to multiply with h. The second term we have to multiply with 2. And the third term we have to multiply with 2h squared. This is what we get. This is what we get. So this is a complete equation that we get. And simplify further, by bringing 2h squared to the right hand side. So the right hand side become this one here, 2h squared dxi. That's the right hand side. While the left hand side, we will have terms involving yi minus 1, and yi plus 1. Two of them, each of them will have two terms. So we group them together. So yi plus 1 involve this one here and this one here. We group them together. This is what we get. Next is yi. This is the first one. And this is the second one. We group them together. This is what we get. And the third one is this one here, yi minus 1. And this one here. We group them together. This is what we get. So we have the complete finite difference formula. So the finite difference formula must be in the order, we need to arrange the terms in the order of yi plus 1, yi, and yi minus 1. It's not difficult because we have them all here. And the right hand side will be 2h squared dxi. So this is the finite difference formula. Okay, so done with that, we can now discuss the sample problem, past example 4. Refer to your notes. So this is a we have it illustrated here. So first we have the finite difference formula. Central difference rules. Y prime, y double prime. So this is the problem here. X squared y double prime plus 1 minus x y prime minus e minus x I y equal 3x squared. And the values of x, the domain is between, x is between 1 and 2. So this is the first boundary value, second boundary value. So the first boundary value here means x0 is 1, y0 is minus 1. The second boundary means x0 is 2, xn is 2, while yn is 3. Left and right. So we need to find y of 1.2, this is y1, y of 1.4, this is y2, then y3, y4. So we need to find y1, y2, y3, y4. H is the difference between the h values. In this case, it's 0.2, while n is xn minus x0 over h. So we have 5. So n is 5. The number of intervals is 5. So with that, we can draw the diagram. This is the one that we get. 5 intervals, 1, 2, 3, 4, 5. This is the first boundary. This is the second boundary. N is 5 here. So we have x5 is 2, y5 is 3, x0 is 1, y0 is minus 1. So we need to find y0, y1, y2, y3, and y4. So 4 unknowns that we need to find. So the first step in solving this problem is to draw this diagram. Make sure you have this diagram drawn correctly so that you know what you are doing. Okay, then once we have that, now we need to find the finite difference formula. We start here. This is the original problem, the given problem. Now we eliminate y double prime and y prime and make the whole equation finite. This is what we get. This is what we get. And then find the common denominator, which is 2h squared. We have a longer equation here. And finally, we need to group together terms involving yi minus 1, yi, and yi plus 1. So we have that here. First is yi minus 1, which is this one here, and this one here. So 2x squared, we factor yi minus 1, this is what we get. Okay, and then the second one, terms involving yi. First is this one. Second is this one here. So this is what we get. And third is yi plus 1. First is this one here. Second is this one here. So we have this. So we get the finite difference equation. So this is the finite difference equation which we will use in order to generate the system of linear equation. Okay, continue. So this is where we are now. Okay, so since the problem requires us to find y1, y2, y3, y4, starting with y1 means I equal 1 that we need to substitute. So with I equal 1, we put I equal 1 into this equation. This is what we get. So we have this one here. So from here, we know the value of y0. So put the value of y0, which is minus 1. So we put minus 1 into, and also the values of x1 all together. So this is what we get. Okay, next, 2.92 times minus 1 is a known quantity. So we bring it to the right-hand side. So we get the first equation. So leave the unknowns on the left side. The known portion, put it in on the right-hand side. So we have the first equation. So the second equation is by letting I equal 2. So I equal 2, put into this finite difference formula. This is what we get. So out of this, we have y1, y2, y3, all are unknowns. So we put them on the left-hand side. While the right-hand side, we get minus 0.4704. So next is I equal 3. Put I equal 3 into this equation. This is what we get. This is what we get. Put in the values that we know, which are x3, just x3 only. So we get the third equation, which is this one. And then the last equation is I equal 4. Put it into this equation, finite difference formula. This is what we get. And then out of this, we know the value of y5, which is 3. And put that value in, and we get this one here. And put this value to the right-hand side. So we get equation number 4. So we get equation number 4. So equation number 1, 2, 3, and 4. So we can put it in a matrix form like this. To arrange in matrix form, we need to put y1 in the order of y1, y2, y3, y4. First equation, y1, y2 are there, but 3, 4 are absent, so 0, 0. Second equation, we have 4, then this value and this value, involving y1, y2, and y3. y4, no value, so 0. And same thing with this one here. Third equation, no y1, so 0 here. And the last equation, no y1 and no y2, so we have 0, 0. So we have the matrix form like this. And we can use the Gaussian elimination method or the Thomas algorithm method to get the solution, which is this. So that ends the discussion on part 5 of ODE problem. Thank you.